Hey guys, welcome back. This tutorial is to set up OSD rendering tools on your Windows machine within the Windows Subsystem for Linux, or WSL for short. It's a workaround whilst Knifa is working on updating the website renderer. First things first. Support for this toolset is basically non-existent, as a more user-friendly web renderer should supersede this. You need to be comfortable with your keyboard, as most of this is command line stuff. The prerequisites for this are Windows 10 or higher. The demonstrated system today is a Windows 11 system. You have no pre-existing WSL installation, although if you have this installed already, you'll likely have been playing with it and know enough about WSL and Linux to take what you need from this tutorial and make it work. And you'll need a recently updated WTF OS system so that you are recording DVR and OSD. This is the recency of this needs to be recently updated for compatibility reasons. The tool supports DVR and OSD recordings from iNav, Betaflight and RGPilot, although the demonstrated test today will be with an iNav recording. Let's get started. So the first thing that you'll want to do is to download the the base code for the tool, and to do this we're going to go to a website that I'll put in the description, and it is simply this website, and all that you need to do when it disappears is to go to code and then download. Okay, so we open up that file, or we open up the location in preparation, and we also need to create a directory. Now this is your discretion on where you create this, but for the simplicity of this tutorial, we're going to create it in our C temp drive on our Windows machine. So here we have C temp, and I'm going to create a new folder called osd-dump-tools. We're going to open the zip file and navigate within the zip file till we get to this level and copy those into this directory. So you can see this is what's in there now. So that's the preparation work we need to do. We'll come back to this directory later because we'll be putting files into this directory from Windows, and we'll be executing the commands from inside our WSL Linux environment. Okay, now that we've done that setup, let's move along to installing the Windows Subsystem for Linux. So all that we're going to do now is open up a command prompt and run it as administrator. This is an important step, otherwise it will fail to run if you don't run it as administrator. Simple command, once it's open, WSL --install --distribution Ubuntu. Download, then install, and then it should start up. Okay, you can see it's starting up. I can now close this command window. Now the first thing you'll need to do is set up a new username for use within the Ubuntu system. I'm just going to use osd-tools as the username. You can obviously use whatever you would like. And I'll put in my own password variation. Remember this password because it'll be used a little bit later on when you're putting in certain commands. Okay, so we have our OSD tools our new Linux environment under Windows Subsystem for Linux installed. It is essentially a shell of a full Linux system with no graphical interface. You'll find that it's now added to your programs. So when you want to run it, you can click on Ubuntu in your start menu. So it will appear there. So we can do things from here. Simply, I can just type in exit and it will close it, and I can restart it, and it will be back again. Okay, so the commands that we're going to be putting in are as follows. I'll put them in the notes. First thing we're going to do is update our Ubuntu repositories. And just sudo apt update. Now, sudo is I guess a command to make sure that it puts administrative privileges on whatever your following command is, so that we can install certain things under that root user. So this is the password that you put in before when you created your osd_tools user. If you used that username, it will download and update all the repositories so that the subsequent commands know what it needs to get and download to install the updates that we need. Once that's finished, we're doing the same thing again, sudo apt, and this time we're doing upgrade, and that updates, and we'll select, we can hit enter or we can just select yes. So I'll just press enter, does the same thing. It updates things that are needed to be updated. It's like a Windows update type of thing. Everything's installed, it knows that it needs updating, and it will download what it needs to and install it. So this is going real time on my system, so you'll see how long this process takes. I have a reasonably fast internet connection, 100 megabit. So you may find this goes faster or slower depending on your internet speed. Okay, done. So the next thing we're going to do is install the main rendering tool, well, the main rendering executable that does all the background rendering grunt work, and that's ffmpeg. Yes to continue. Okay, next step along is to install some extra things, but let's just move through these steps. Mostly it's Python related, which is the scripting tool that makes all this work in the background. Make sure we've got the latest Python installed as of creating this. And it says it's already the newest version, which is okay. On here, just install so Python can run in its own virtualized environment. Okay, so now we are at a point where we need to move to the directory that we actually installed. Sorry, we copied the files to before. So this is temp.tools, the directory. To get to that under Ubuntu, we are simply executing a cd command, and we're going to mnt, which is where all of the file systems are mounted, and it's on our C drive. It's on our temp directory under C drive, and it's the osd-dump-tools directory. So if I do an ls command, which is the same as a dir command or a dir command under Windows command prompt, you'll see we have the files as here, noting that anything that starts with a dot is hidden from this standard ls command. If we want to have a look at everything that's in that directory, including anything hidden, as long as we've got access to those hidden files, just ls -la. Excuse me. Okay, so we're in that directory. Now, the next command we want to execute is to pretty much run up the virtualized Python environment and set up this as something that will be able to be run at a later stage. Excuse me. You'll notice there's a new directory that was created, and this is where the links to the Python environments are created under there. So now we're going to activate that so it can be used later. And now we are going to install some of the requirements, or the subset of requirements required to run the OSD conversion. Okay, now it's done. All we need to now is restart Ubuntu. So we're going to exit. And we're back on. Notice that our current working directory, and you can see that by using the pwd, print working directory command, tells you where you are. At the moment, we're in our own encapsulated home OSD tools, being the user we created location. So we need to move to where we installed the OSD tools. So again, mount C drive, temp directory, osd-dump-tools. We're back there again. So you can see the content of the directory. So that's pretty much it for the install process. Now we get to the commands that we can use. So the first thing that we need to do is to, or the things that the command line needs to execute is your DVR file, your OSD file, take it from the goggles, and the 4 font files that you want to use to render the OSD and have an output. So I'm going to excuse me, copy those things. So there's the 4 font files, and here's a test of a recording and an OSD that I'm going to place in the same directory over here. Going back to Ubuntu. And the command we're going to be using is Python 3.8 -m, and we're using the OSD package. That is what we've taken from the OSD tools. We're putting in the fonts, and in this case the font I know that's in the font file is an INAV font, so INAV. If you were doing this under Betaflight, then you would use BF, because your font files would be named font_BF, or under arduplane or ardupilot, then be font_ardu. And those files, the font files, will need to live in this directory as well. So it's a high def recording and it's 16:9. So we use wide, and then we simply give it the name of the DVR file only. It will assume that the OSD file is named the same name, but with an OSD extension. Green.mp4. Now, when this does its thing, you'll notice that you'll now have in the same directory a green _with_osd.mp4. It doesn't alter the original file, but creates a new file. Noting this is a reasonably small file, so when you have a large file that is 2 or 3 gigabytes, if you're using it that large, it will take a long time to do. So you can see here the new green with OSD has been created. I will open up the original so you can actually see. There is the original. It's empty. You can see it's progressing along the timeline. There's nothing in there. Green with OSD. The OSD is overlaid on top of it. Now this is a little bit skewed, and that is for the reason that this particular OSD recording was made with a development version of iNav that has the ability to move the elements out to the far edge of the screen. So when that becomes available, your command in the command line will be the same command except fake HD. This will overwrite what's there. You'll see there's timestamp change from 11:33, now it's 11:34. It's creating the file. Okay, it's done. So you can see now it's all aligned and everything out to the edge of the screen based on what you will likely find in iNav version 6 when released, the ability to move things out to the edge of the screen when you're selecting the correct OSD configuration in the iNav OSD tab. Okay, let's try a different file so you can get a bit of an understanding of what else or how this would work as well. Now here's a test file that if you looked at the original tutorial I did with getting all of this working under WTF OS, this is the file I created. So going back here, same thing. I know that it wasn't a widescreen OSD setup, so that's fine. And we're giving it the file name DJI, G for goggles, 1 2 3 4 zeros. Okay, so the original file looks like this. That's just blue tape put over the camera. So you can see it's empty with OSD. This was the sample OSD I rendered the other night, or I created the other night. So you can see that it works as expected. Okay, so you may have also noticed that recording on your DJI goggles, the DVR is split. At least on my goggles, it's split at exactly 10 minutes. So they get split out onto the SD card on the goggles. And the rendering tool on the web at the moment has difficulty with the fact that it can't deal with multiple files as of recording this. What the osd-tools or the osd-dump-tools can do, well, not the dump tools themselves, but by the things that we have installed up to this point, we can actually combine those files quite easily in the WSL command line. So an example of this is I've put a directory under the dump tool. I'll just call it X, call it whatever you like, but for this example, we've got two files here. They are from a flight video, and it's actually longer than a 20-minute flight video, but you can see that we have two files subsequently named 1.5 gig and 1.7 gig, both of exactly 10-minute length that the DJI goggles has saved them as. What we're going to do is combine them into a single file. You could have more in this. In fact, let's actually, let me find the subsequent file. I'll just pause this video while I grab that and put it in there. Okay, so we have a complete flight of 22 minutes and 18 seconds when these are combined. I can open up each of those and you can see that right at the 10-minute mark here, we cut out flying over this fence here. The next one we pick up flying over that fence, and then we are, I guess we're doing a split S type of maneuver on the plane. And on the final one, we're picking up that maneuver, and then we're coming in and actually doing a landing. So you can see it's a full video, 22 minutes. So to combine them, we are going to essentially do this command, and I'll put it into the notes. It is using the ffmpeg command to concatenate essentially all the files in the X directory. So make sure that there's nothing else in there apart from the ones that you want to concatenate, and it will concatenate them in logical order. So 60, 61, 62. So we execute this from the dump tools directory. And what this is doing is essentially creating a statement to feed into the ffmpeg to give it the full path to the files, and everything that has an MP4 extension on it. And it will copy it to a file that lives in this directory, and it will call it xxx.mp4. So let's go ahead. That's creating the file. It will combine the three, and actually takes quite a quick amount of time to do so. It's simply a matter of, it's a data copier essentially. Okay, so you can see here MP4 is 3.7 gig of this file, and it's a combination of these three sizes. If I open up the file, you'll see it starts where it started. We get to the logical 10-minute break where it flies over the fence and it continues on without missing a beat, as you can see. Heading to the next 10-minute mark. We'll be going out of a split S, and then it just continues as per the next video file in the DVR. And it concludes with a coming in for a landing. So that's how you combine them. Now I will essentially prove to you that the OSD can be rendered on top of this. So I'll just take the green OSD and put it on top, only to show that the OSD can go on top of it. The OSD doesn't have to be the same length in this tool. It will just crop to the video length, or if the OSD is shorter than the video length, it just pauses the OSD essentially static on the screen at the end of it. I'll just copy and paste this and call it XXX.osd, and in our tools we want to, I'm just using the up arrow to get to previously commanded things here. So I know the green was a wide, so I'll use the fake, and I'll grab the file XXX, so I know that there's an OSD file there for it. I'll kick this off and I'll probably pause it because being a 3.7 gig file, it's going to take a while, but I'll kick it off and you'll see, and come back when it's finished. Just jumping in here, you'll notice that on the main rendering section here we've got a speed. So this is frames as you'd expect. So it's doing it at the moment on my machine roughly 2 times, and we know that it's 22 minutes for the full file. So I expect this to be completed in about 11 minutes. Okay, we're back again. It has finished, and we have a OSD rendered overlaid file. Let's open up and see what it looks like. So this is obviously not the OSD that belongs with this file, but you get the idea. So at the point, you can see that the OSD is working, it's running, etc. When it runs out of time on the OSD file, it just becomes a static image on the rest of your video. So you can see here that all successfully overlaid. To the point where we come in for landing and we conclude the video. So you can see that reasonably simple to combine the file and then take your OSD that you recorded with the first file, because that will continue for the whole duration of your flight or whatever you're doing. Even though the DVR is split, you combine the DVR, you lay the OSD on top of that, and then you're good to go. Hope you find this useful. Leave your comments down below if you find it useful, etc. And we'll see you on the flip side.